All right, so moving on to section 14.2, we're solving these trigonometric functions. So now that we kind of have a basis of simplifying and everything and need some basic identities, now we can use some algebra to be able to find exact values or values of trigonometric functions to find what like the x value is, where they would intersect when it would be a certain point. So here's kind of the basic rules that you have. So the first thing you want to do is get whatever the trig function is by itself on one side. So it's going to be trig of theta or trig of a variable or trig of 4 theta, something like that. So you want to get the trig function all by itself, sine, cosine, tangent, cosecant, yada, yada, yada. Once you have that, what you have to do is you have to try to get rid of the sine, cosine, or tangent. And to do that, you use the inverse sign, which is also called the arc sign, or on your calculator, you'll see it as sine -1. That's not saying the inverse, you're taking the sine -1 on both sides. Okay. Now, you want to make sure you're either in degrees or radians, depending on whatever the question is asking for. And again, you change that by going to mode and changing it from degrees to radians. So once you get the trig function by itself, you get rid of the trig function by taking the inverse of it, which is going to be on your TI calculator second, and most other calculators that have the trig functions second, and then either sine, cosine, tangent, whichever one it is. Okay, you do it to both sides. Okay, so let's do an example. So let's say we have this one. So we have 2 cosine theta minus root 3 is equal to 0. Okay, so we have 2 cosine theta minus root 3 is equal to 0. And what we want to do is we want to find what theta is. So that's our variable. Theta is our variable. So the first thing we would do is we'd move everything that's not attached to the cosine to the other side. So we'd move that root 3 to the other side by adding it. And then once we have that cosine by itself, we divide by 2. Okay, so now we have this function. So now we have cosine theta is equal to root 3 over 2. And that's all we're trying to do. We're trying to get cosine theta all by itself. And you just use your algebra skills. Adding and subtracting, you do the opposite moving over. If it's something being multiplied, you divide it. If something's being divided by it, you multiply it, yada, yada, yada. So it's basic algebra skills all the way through. And then once you get your cosine theta equals root 3 over 2, what you want to do with some of these is you'll be able to look in your trig function. So root 3 over 2 actually appears on your trig function. And so what you're going to do is that you're going to look through your trig function and go, okay, where is cosine root 3 over 2? And it's located at 2 places. It's located at pi over 6 and 11 pi over 6. Okay. Now, cosine theta is equal to root 3 over 2 actually an infinite number of times, but we're just going to be looking at them within usually the first full circle, so between 0 and 2 pi, or even less, even just the first 90 or 180 degrees. So in this case, if they appear on your trig function, you want to write it. Now, if it appears on your trig function, it's going to appear twice. Okay, so root 3 over 2 appears twice on it. Negative root 3 over 2 also appears twice. 1/2 appears twice. Negative 1/2 appears twice. Root 2 over 2 appears twice. 0 appears twice. Yada, yada, yada. All those numbers appear twice. Okay, and so you'd want to write both of them if it becomes a nice solid number. But again, get it by itself. And this one you don't need to use your calculator because it is on your trig function. Now, let's assume that you don't have your trig table, anything like that, and you have a problem like this. So you see with this one, we have multiple trig functions. We have tangents. Another way you could do this is to change tangent theta into your variable. So you could rewrite this if you want as 3x minus 1 equals x. And you use that to help you solve it. So what would you do to get x by itself? Well, okay, I can subtract x, add 1, add 1. So now I've got 2x equals 1, which gets me x is equal to 1/2. Now you just replace the x with tangent theta equals 1/2. Okay. So now we have tangent theta is equal to 1/2. So if you have multiple trig functions, as long as they're not squared, as long as they're the same trig function, you can add them and subtract them like you would a variable. So now we have tangent theta is equal to 1/2. Now if you look at your trig table, you don't have a tangent of 1/2, okay, which is fine. So now this is where you would use your calculator, and you take the inverse tangent of each side. And when you take the inverse tangent of each side, you end up getting your answers down below. But what happens is that when you take the inverse tangent of a tangent, or the inverse sine of a sine, or the arc cosine of a cosine, those cancel out, leaving you with just the variable. So you have the theta is equal to inverse tangent, or the arc tangent, of 1/2. Your calculator will actually come up with one answer for it, which will be probably be the 0.46. Okay, so with these you only need one answer at a time. You don't need both. Okay, so you just need one. Okay, so now with this one, what we have is that we have our sine and we have a sine squared. So with this, we just continue our algebra skills, and what we would do is that we'd remove a sine from each side. So removing a sine out, now we have our two factors. We have sine theta and we have sine theta plus 3. Since they're both equal to 0, we can set both of them equal to 0. So we can go sine theta, this one, is equal to 0, and we can solve it, which gets us either 0 or pi, which is on our calculator, or which is on our trig function. And then our second one, we have sine theta plus 3 is equal to 0, which means we have sine theta is equal to -3. Now, if you do the inverse sine of -3, you'll see that it'll come up with no solution. Okay, it'll say something like not in domain or not in the range. It's not going to come up as an answer because sine and cosines have to be between -1 and 1. Anything outside of it is no answer. So we factored out a sine from each side. We set each segment equal to 0, and we solved. Our only answer would end up being 0 and pi, because those are the only ones that work. -3 we can't get for our inverse sine, which means that's not an answer. Okay, so just make sure you look out. Again, you can use your calculator for these to find what your answers are.